Okay. It says, given the system of equations, determine a. It says determine. I guess I should change out the color of this so we can distinguish it from my own work. There we go. Determine the type of graph that each equation represents. Well, I think the first one's a circle. The second one is a parabola. All in agreement on that?
Yeah.
Okay. B says, list the number of possible solutions when given the two function types of you listed in part A. Oh, well, I think there could be 4 solutions. If you think about a circle and then a parabola on top of it, I think there could be possibly 4 spots where there could be an intersection. Can't think of a way that there could be more than that.
So you're saying there's 4. So I know there's. How did you find the 4 answers? How does that?
Oh, yeah. So it's to support your answer with sketches. For example, 2 linear structures have 0.
List possible solutions when given the 2 function types. Part A. Yeah, I'd probably say there's about. I think there's only 4 because you can only. Well, I guess with the circle there could only be 3, right? If you have a circle and a parabola.
There could be 4.
Those
Oh, wait.
Well, I guess unless the parabola is like above the circle, that way its vertex is above it, then it might cross the circle in 4 places, I guess.
Yeah, that would make sense to me.
You know, I was just thinking there could also be 5 possibly. Let's see if I can't. Am I not screen sharing no more? Probably not. Sorry about that.
We forgive you.
Let's try it actually.
I'd assume there's only 4. I can't think of another way to get 5 unless if it's like a really, really wide parabola.
No, I can only think of 5 or 4 as well.
But you may be able to get 5.
There's infinitely many, as long as the parabola curves perfectly along the circle.
That's true. Oh, darn. I don't think of that. Yeah, the parabola curved perfectly along the circle.
I don't think it could, though.
That would still only give you
a limited number.
Like it couldn't follow for more than one exact point.
Yeah, I think it's only 4. Looks like it could be a logo, almost.
Yeah, I'd say 4. I can't. I don't think it'd be a parabola anymore, even if it did try to fit along the whole circle. So I feel comfortable saying 4.
Yeah. I need to solve it. What's to solve that?
Support your answer with sketches.
So, I mean, to support your answer with sketches, all you'd have to do is you don't even have to graph it. You could just draw a circle.
Sorry.
Parabola.
I forgot what wasn't screen sharing. Oh, dear.
I'm going to try and put in some points and see if I can't find the 3 points where these parabolas do it, because the easiest way that I found out is just to put in a number for x and then solve it.
Well, for this is asking any general, circular parabola. Is there any possible way?
I think that's good. Except for, I don't know if it needs to be accurate to the equations, because if it does, the parabola would actually be flipped because of the negative in front of the x.
No, this is just general. This is a general purpose sketch.
Okay, I'm just saying.
It's all good. It's all good.
So if we have x minus 4 squared minus 2 squared 9. So for a plug numbers in,
Are we solving right now using the system of equations?
Yes, we are. Well, I am anyway.
1.
Us to race you?
Hmm?
Do you want us to race you?
I mean, if you want to.
That doesn't make sense. Oh, that's right. All right, I don't think that's right.
What do you mean?
Well, I just tried to put in a number for the second equation for x, but the squared throws it off. So 1 equals 30, but I don't think we could get up to 30 in this parabola. It's a pretty big.
There's only one way to find out.
Five. So when I put in 4, I got 5 out. So I know that in the second equation, 4 and 5 is probably the height of the parabola. So I don't think I can go any higher on that. When I put 2 in, I got 1, but I don't. 2 and 1. 4, 5, 2 and 1. Well, I don't know if this works for this one. 0 and negative 11.
What the freak?
It's only a freaking long equation.
So if we draw the circle, because we know that there's 4 and 2 for the y, that's the center, and then the third, take the square root of 9 is 3. 3 would be the radius. So the top of the circle would also be 4, 5. Because of the radius of 3, and if you go up from 4 and 2, that'd be 4 and 5. All the way around. I don't think 2 and 1 cross the circle. So I know 4 and 5 is 1 because that's where the top of the parabola was and where the top of the circle hits.
Hmm.
Which would mean that this one would be 7 and 2. This one would be 1 and 2. This one would be 4 and 5. And the bottom of the circle would be 4, negative 1. So I know the parabola hits at the top point. 4 and 5. I got 2 and 1 instead of 1 and 2. The parabola. But why does that come out so weird? So that's the circle. So I need the square. And so if I put in maximum is 4 and 5. If I plug in a number, I don't understand how this works. So if I plug in a 0 for the parabola, like if I plug 0 in for the parabola, I get negative 11. So it'd be 0 and negative 11, which might be the very bottom point. So if I put 1 in, maybe 1, I get 1 and negative 4. So we're working our way up. Now this is 4 and 5. Then we have 1 and -4 and 0 and -11. This is 1 and -4, 0, -11. If I put 2 in, I get 1. So it's going to be a decimal then, I think, because
Indeed.
1 and -4. So I think we're going to have to do a different method because, well, I don't know. Bye, love you, have fun.
Love you too.
Because here's all the points that I got for the parabola, which it's probably backwards and not very clear. But that's what it looks like. And so the points that I got end up in the middle of the circle. Where is it? That's where all my points end up, is right there and there. So we need to find a decimal that would land on the edges of the circle.
Mm-hmm.
It's going to be between, because 1 is -4, so it's got to be between 1 and 2. But I don't really know where. Well, I guess if I plug in all of the decimals and tenths, that'd take forever. Where does 1.5 put us? 1.5 land at 0, I believe. If we get it to land on the x-axis both places, so that's still too high, so 1.6. Huh. We're getting 7. I'm still getting 0.29. 1.8 is too high, so apparently it's a decimal between 1.7 and 1.8. Seven one is not quite right. 7.2.
Interesting.
4. 5.
I'm like getting all sorts out of whack. I'm trying to find it by doing the substitution method, but I can't figure out what the zeros for the first equation are or for the second equation exactly are.
Mm-hmm.
Well, the one that I found nearest is 1.764, and that was literally just by plugging it in, and then once it went too far, I added another decimal point. That one gave me 0.
All right.
So if we could find the zeros for the second equation, and then we put both of those zeros into the first equation, that would give us 4 answers, because we'd be dealing with positive and negatives because of the squares, the square roots.
Well, I don't think we deal with 4 answers because the circle doesn't go past the negative on the x except for the -1. And in that, the parabola won't reach it. So I think on this one, we're only dealing with an x of 3. Because all the numbers that I plugged in draw the parabola way too far down past the circle to even count a negative in.
Oh, really?
Yeah. So I think we're doing, this one has 3 crossing parts. And the one that I found right now is 1.764 gets me 0 on the parabola hitting the circle. But that's just straight plug and chug on the way that I like to do it, where I just put in numbers until I can figure it, until it matches up on the.
So it gives you the right answer.
Yeah, because what I literally did was I did 2, which I noticed was too high. And so then I went from 1.1 all the way up to 1.7, and then I did 1.8, and that went too high. And so I went 1.7, and then I did 1.71, 1.72. Until I got too high, and then I got to 1.764, and that finally got me 0. So I'm sure there's a much easier way than doing that, but I just plugged and chugged.
So what I did was I took the first equation and subtracted it from the second equation and simplified it and got me down to this, which gave me y equals to 5 and y equals to 0. So I plugged in 5 in for y in the first equation, then y in for y for the second equation. When I plugged in 5, it gave me x equals 4, and then when I plugged it in, it gave me plus or minus root 5 plus 4. The second one from simplification.
But don't we have to still find the other 2 points? Because that gets you 4 and 5, which is the height of the parabola and the height of the circle.
Do I just want to find where it intersects?
Yeah, but this one intersects at 3 points.
3 points. Let me see here.
Which y gave you the x of plus or minus square root of 5 plus 4?
0.
0? So then we have our 3 answers, don't we?
I think we do. I'm just going to check to make sure.
I don't believe we do.
He's a non-believer. Just kidding.
I am. Because I found 1 point by doing my plug and chug method, and I got 1.76 is 0.
Oh, yeah, that'd be what the root 5 plus 4, I think, equals that.
And then there's got to be one more at that point on the other side of the circle.
That'll be the negative one.
What does the negative root 5 plus 4 equal? And I'll plug it in and we'll see if it gets us to 0 on the other side of the circle.
That's
Negative square root 5 plus 4.
uh-huh.
Is the 4 supposed to be in the square root as well or no?
No, out. Definitely out.
It's negative square root 5 plus 4 is 1.76.
Well, that's the one I got. That's the first point, 1.76.
So try just positive root 5 plus 4 then. Not
That's
negative.
6.23.
Yeah, that's the other intersecting point. So we have all 3.
So 6.23 does get us to 0. So
Yay.
So it comes out to be 6.236. So I'd probably put down all 3 points then. So I'd put 4 and 5, 1.764 comma 0, and then your 6.236 comma 0.
I would do that, but look what it says right here. Give exact answers.
I know,
So,
isn't that my exact answer? Is the 1 point and the 6 point?
This is
No.
what
Those are rounded decimals.
So in my history of math, I've always said to give radicals when they said that, but I don't know.
Okay.
Crazy.
Maybe you could just put both. That way we cover all bases.
True. I'll give the answer then the.
Yeah, give the answer and then the rounded decimal as well.
Yes. Whoops, I don't want that. I don't want that.
That way we get everything in there.
What the hell did you do, dummy? Gosh dang it. For real.
Reals, bro.
That's why I don't like Word, guys. I do not like Word.
They be climbing in your windows, snatching your people up. Hide your kids, hide your wives, and hide your husbands.
Because they're raping everybody out here.
Do you know on his song that he made $11 million when that person made his little song?
That guy did, or the guy who made the song?
The guy did, just in like sales, basically, just because he got a portion of all the sales.
Of all the views?
Yeah, from all of the views. And so because of that, he literally made like $11 million and he's living rich. I watched a show called I Became Rich Overnight, and he was one of them.
That's actually freaking sick. That's pretty cool.
Can I be on that
Freaking
show?
crazy.
Wish I could be on that show, man.
I know how to
Joke.
learn how to get rich overnight.
Okay, there. So I put the X and the X's and then their points just to make sure.
Perfect.
So we're covering all our bases. Okay. It says here, when Sarah and John work together, maybe I'm thinking they are. They're pioneers. How cute. They can move their handcart 3 miles an hour in 3 miles in 5 hours. Sarah takes 1.5 hours longer to move the handcart the same distance when she is working along than it takes John. How long does it take John to move the handcart 3 miles when doing it by himself? It will take him longer when he works with Sarah. Just a little bit sexist, but it's all good. It's all chill.
Oh my.
It's not sexist. Sarah's just slower.
Of course, it's the woman that has to be slower. Yeah.
You didn't have to. It's just coincidence.
Oh, sure.
There are no coincidences.
Oh, okay. We'll put the variables as S and J because it's Sarah and John. So when Sarah and John work together, that will equal 3 miles in 5 hours. 3m times 5h. It takes Sarah 1.5 hours longer. What the heck? Takes Sarah 1.5. Okay. 3 miles plus 6 times 6.5. Each. Alrighty. How long does it take John? That's the question of the day. Okay. So according to your hint, it says that this 5 hours should be shorter for down here. That's kind of
So
messed
this
up.
gives us a time that it took them, right?
Yeah. So them together, S plus J, will be 3 miles in 5 hours. Sarah by herself is 3 miles in 6.5 hours. And what we want to know is how long it'll take John.
So what I would do instead of having the 3 miles times 5 hour, well, I'd put the 3 miles by itself on one side and then do the S and J with the 5 hours.
Like another equation?
Well, just because.
Oh, it's 3 miles. Yeah, it's 3 miles. Any way you look at it, it's 3 miles. True. That's not really a variable. Good point. Maybe. I don't know. Maybe I'm smoking something.
Well, because your 3 miles is your set variable.
Yeah, so it's not really. It's the constant, if you will. What the
So take to move the hand cart 3 miles and doing it by himself. Oh, and this isn't sexist. It's saying it will take John longer than when he works with Sarah. Not that it takes him. Not that he goes faster.
Well, yeah, that's what I'm saying.
I know. I took it as John would move it faster than when he was working with Sarah.
Yeah, that's what I understood it as. But
Oh.
now I
That's
feel
a-
personally offended.
Equals.
Well, yeah, look, it says there. It will take him longer. Oh, yeah, there we go.
Man, that's the key word.
Comma, Mr. Hess.
There it is.
Comma, Mr. Hess. You're changing the whole meaning of the phrase. It will take him longer, comma, than when he works with Sarah.
Okay, so if Sarah takes 1.5 hours longer to move the handcart the same distance, so I'd equal everything to 3 because that's your constant. 3 miles, 3 miles, and 3 miles. So we're going to have 3 variables because we have distance. Wait, what is it? Distance equals rate times time? What is it? What's the distance thing?
Nobody knows.
Because it's 3 miles, regardless. They're all trying to go 3 miles. And it takes John.
Nobody knows.
Hang on. So if Sarah takes. So we have S plus 1.5 hours longer. So we have S plus 1.5 R because you've got to times it by the length. And if they work together in 5 hours, it's going to take Sarah is that saying that it's going to take Sarah 6.5 hours
Yes.
to move it the same distance?
Alone, yes.
So it's 6.5. And then together, if we split it, 5 divided by 2 is 2.5. So you have 2.5 S plus 2.5 R. And then how long does it take John to move the handcart?
It doesn't say. That's what we're trying to find.
3 miles when doing it by himself.
Doesn't say. Unfortunately.
So we're trying to solve for J, right?
Yes, we're trying to solve for J.
We have S and J equals 5, and then we have just S equals 6.5.
Uh-huh.
So, I mean, we could just substitute it and put in H for S.
Oh, that's true.
But that would you?
Would that work though?
I don't know how you'd get that because it takes him longer, so it has to be longer than 5 hours. So I don't think it's going to take longer than Sarah, but that could be sexist, so never mind. He could take longer than Sarah.
He could. He could have like a broken leg that we don't know about.
Yeah. So maybe what we need to do is go S minus J equals 5 hours because
Oh, that's
if S
true.
plus J equals 5 hours, well, you can leave that. I'm just If S plus J is 5, I don't know. We got to use a distance times rate times time thing.
Yeah, there's something screwy here. Oh boy, that's gonna be nasty. Boom, boom, boom.
So what
Yeah.
if we were to graph this? I mean, would that help us visually?
How would you graph it?
I don't know, just draw some pictures, do something. So we have dang, I don't know.
Okay, so it's R times T equals D, so the distance. So it's rate, which is your speed,
Well, you know what I was just.
times time equals distance. So we've got to find the rate.
Yeah, why don't we not do it in hours or time, but find the actual miles per hour? That might help. But they move 3 hours in 5 hours. How many miles are they doing per hour?
So we move 3 miles per 5 hours.
Mm-hmm.
We're moving 0.6 miles per hour. So in 5 hours, we have moved 3 miles.
So 0.6. You said 0.6
Yeah.
miles per hour. And Sarah was doing, what was she doing again? Oh, so it'd be 3 divided by 6.5 again.
So this is rate times time.
3.4. Now that makes no sense.
The distance of 3 miles.
No,
So we have Sarah at, so if we do this, if we find Sarah's, because we know she does it by herself at 6.5 hours, right?
Uh-huh.
That would be her rate. Wait, no, that's her time. We need to find the rate.
The miles per hour, yes.
So if we have S times her 6.5 equals 3 miles, could we just divide it? And that would give us the S, and then we could plug it back up in from S plus J equals 5.
I don't know. She went 3 miles in 6.5. 0.46. Did it right. Yeah, I did it right.
I just don't know how to find the working together thing. It's 3 miles per hour.
Oh,
So
we're
you just divide 3 miles per hour. So that's 3 miles per hour. So you just divide 3 by 6.5, right?
Well, no,
Sure.
it's not taking that it's not saying that it takes her 6.5 hours to go the 3 miles. It's saying that it takes her an hour and a half longer. Hold on. I'm reading it wrong because then it says it would take John longer. The Sarah takes 1.5 hours longer with the handcar the same distance when she is working alone than it takes John.
With John. Then it oh. What the frick? You're right. Sarah takes 1.5 hours to move that handcart the same distance when she is working alone. Then it takes John.
Yeah, so it still
We have
takes.
to find John first in order to find Sarah.
Well, we're given.
No.
So
Wait.
Sarah, John plus 1.5.
Oh, so you're doing S plus J times 1.5 or S times 1.5 plus J?
I would say S equals J plus 1.5.
That makes sense.
Okay.
But then where does the 3 miles come in?
It's
Equals 3.
miles is the constant. It could be 1 mile. It could be 3 miles. If you're setting this up as a fraction, then it all makes sense. So it would be S plus J equals 3 over 5. And then S equals J plus, yeah, I think that's right. Because, that gives you the same 1 hour's longer. So, but they're still going 3 miles. So 1.5. 3 miles. No.
Do we even need the 3?
Yeah, so it'd be 3 over 6.5. So S plus J, or S equals J plus 3 over 6.5.
Oops.
So those are the equations we're working with.
Okay, there's still an unknown though.
Why'd you put the 3 over 6.5 though? Because we don't know if it took her 6.5.
No,
It took her an hour and a half longer than it takes John.
right. But it took them together. Hold on. God, this question is worded so weirdly.
For real though.
No, I think you're right though. I don't think we
I
need
don't think 6.5 is a thing.
Yeah, I don't think 6.5 is a thing either. So it'd just be 1.5.
Freak. So we have distance times rate. No, distance equals rate times time. So our rate would be the 3. No, because the distance would be 3 miles. The rate would be
Nobody knows.
their average speed.
I didn't see anything like this in the homework.
For
I
real
didn't
though.
either.
I don't know what she's trying to pull here.
I feel like she's been trying to pull stuff like this since week 2.
For real. I mean, this I've seen.
Yeah.
And I think I have no idea. No idea.
That does not look fun at all. I don't want to do it.
But this, man, I mean, there's a hole in it, though. When Sarah and John work together, they can move the handcart 3 miles in 5 hours. Sarah takes 1.5 hours longer to move the handcart the same distance when she is working alone than it takes John. What?
Okay, so we have, what do we have? We have the distance. So we have a distance that's been established 17 times by me. We have our time of them together is 5 hours. So that's the time is 5 hours times S plus J. And then we have for Sarah equals 3 miles. Because we need to find Sarah's rate.
Which we don't know.
So hers would be R equals rate equals distance times time, which is 1.5 plus
J
J
times 3.
times 3. And then we have John. And we know John, it takes in order, so J equals 3 times, because he still has to go the 3 miles. He still has to go the 3 miles, so it'd be 3 times, and it takes him longer than when he works with Sarah. So it'd be 5 plus T. Because we got to find T, but we don't have a way to find T. Maybe, oh, because it's times Sarah, so we need to do times S. So it'd be J equals 3 times 5 plus S. No? How long does it take John to move the handcart 3 miles when doing it by himself? So we need to first solve that first equation where it's 3. I did 3 equals 5 times S plus J. So do we need to find S first because we have all of the variables? I think we have to find John's first, right? Because John, if we find John's, we can find Sarah's, and if we can find John and Sarah's, then we can get to the 5 hours. So if we have John, who takes longer than Sarah, take him longer than when he works with Sarah. I think that's throwing us off. I don't think we need to worry about it takes him longer than he works with Sarah. That's just saying as long as it's longer than 5 hours. It takes him longer than 5 hours, right?
Yeah.
So I think that's what's throwing me off. We don't need, in John's, we don't need the Sarah part. We just need to figure out how long it takes John to move the handcart by himself, which is longer than 5 hours.
Mm-hmm.
So if we have, so we have a 5-mile trip. We don't know their average speed.
We have a 3-mile trip, but yes.
What did I say?
5 miles.
We have a 3-mile trip. We don't know their average speed. And we don't know their time.
Individually, yes.
But together we know their time.
And their speed.
We know their speed together. What's their speed?
I mean, it's 0.6 miles an hour.
Oh, is that 3 divided by 5?
Yeah.
Mm-hmm.
So their speed is 0.6. So now we can do 0.6 times. Now we just got to solve an equation. Maybe this is in the homework. Do you remember when we had to get rid of a variable? And we had to multiply it by something like negative J? Or we get rid of John's?
Possibly. Well, that could be.
Because in the bottom one, we have S equals J plus 1.5. So if in the second equation we subtract J over, then we have 15 plus J time over, and then we add that all together and get a whole bunch of hoopla.
Hey, boy. Oh.
This is a long group quiz. There's a lot of parts to this.
We're not even down to this nastiness.
Yeah.
Would 6 2/3 hours make sense to you guys? Like if it takes John 6 2/3 hours to go 3 miles.
Makes sense. I mean, it fits the bill.
Wait, so we know how far it takes both. Well, we know how far it takes both of them. To
Yeah,
go
so
3
I did.
miles, and the speed, and we have their time. So we have all three variables for the first one. So if we use 0.6, assuming that they're traveling the same speed alone,
Well, they can't.
what if we take the speed and then times it by 2 because they're less? They have to do twice the work. So what if we take 0.6 times it by 2? That actually increases our speed, so we'd have to divide it by 2. We have to go 0.6 divided by 2, which would get us 0.3. And that's probably how fast it takes them to go. So we have 0.3 as their speed.
But they don't work at the same speed, though, alone. And we know that because it takes Sarah 1.5 hours longer to move at the same distance than it takes John.
Dagnabbit. Oh no.
What?
Oh, I was just maybe not. Let me see.
All right, maybe we should move on to the next one. Maybe we can come back to this one.
Sure, why not? Oh, whoops. Darn it. Did that thing again. That's what I was not supposed to do. A construction company frequently builds garages with an arc over the garage, similar to the one in the figure below. In order to build each arc, they need to consider the entire circle. Thus, we have the center of the circle. Thus, where the center of the circle is and the radius of the they need to just consider the entire circle, comma, thus where the center of the circle is and the radius of the circle. Currently, they get some check until they get the correct height of the arc. For your information, the construction management student at BYU, Idaho, brought this question to the mathematics faculty member for assistance in solving. Interesting.
Well, thank you, sir. Ruining our lives.
If the garage is 18 feet wide and the owner wants an arc to have the height of 12 inches, what is the radius of the circle which is necessary to cut the arc. It is necessary to cut the. Why would you want to cut the arc?
Well, it's just saying for a full circle, all they're doing is building a full circle essentially.
Yeah.
And then from building that full circle, they're then cutting it in half to make it an arc.
Yes.
So it's 18 feet wide. That means it has a radius of 9 feet, has a height of 12. What is the radius of the circle that is necessary to cut the arc? Yeah, it's 9, right? Scroll down a little bit.
Is that what it is? Is it really that easy though?
Gives us there. That's the radius. Unless the circle goes out over the garage, but then that's kind of a pointless circle.
No, that's not. It's not 9. That's this. The whole circle is like, yeah, the circle does. It wants us to find this length because the radius is this. Right, yeah, that dealio. The garage is 18 feet. The owner wants to have the arc height of 12, so he wants the garage to extend out that 12 inches. What is the radius necessary to cut the arc? Yeah. So what's the radius? What's this length necessary? So we can measure. So if this is given 9 feet, then you want to find this length, right? The hypotenuse. Oh, remember the lab cosines, guys? 90 degrees, 9 feet length.
Like, this isn't even what we're doing anymore.
Just trying to trip us up. Prepare us for the
Right now,
final.
just remember it. Okay, so if we have a right angle, right triangle, we can cut it off at the radius, right?
Yes.
Of the 9 feet.
I think so, yeah.
So that would mean that would also, the top part and the 12 inches would also equal 90. So that gives us our angle side, or our side angle side. Well, that's not a perfect triangle, so that wouldn't work either.
Oh.
How tall is the garage?
Nobody knows.
Why did they build a center of a circle the same exact height of a garage?
Who knows?
Okay, so we can use the 9 feet and the 90 degrees to find a side, right?
Yes, we can.
Okay, so what does that equal? If we find the other side, we can find that one.
Oh, there's a B. There's a part B. Oh, I thought part B was another question. It says, this question can be answered through building and solving a system of nonlinear equations. What? It may be hard to consider a system of equations without a grid behind this picture and some labels. So to assist you, this equation, a more detailed picture is provided. Oh, thank you. C. Write a system of 2 equations with 2 unknowns, r and y, and solve the S system of equations. Frick. How does that even work? How? Just how? This makes no sense.
A system of nonlinear equations?
No, it just says 2. Oh, does it say that? Yeah, it
So
does.
this can be answered by building and solving a system of nonlinear equations.
Mm-hmm. Well, a way to make that problem more impossible. Two non.
Why is the circle bigger than the garage? I'm so confused with that.
Because it's an arc.
I know, but that's I just don't understand why you need a circle that's bigger than the garage in order to put it on top of the garage when you're just cutting it in half.
My question is, who wants an arc for the edge of their garage? That makes no sense.
Is there more?
Nope, that's all we get. What? I don't know how you would be able to use the system of equations to solve this. We have two equations, it says.
So one equation would be equal to 12 and one would be equal to 9.
Or is it 18? I don't know. System two equations with two unknowns unknown and solve the S system of equations. What is the S? What is S? What is S? What is S? That's what applies here. The two unknowns should be R and Y, and S should be the system of equations. S should be the answer. What is the answer, though? What? This makes absolutely no sense.
Our system of two equations with two unknowns. So we have the R. Oh no, we don't.
No, we don't. We don't have the Y either. I just don't get it. Why?
So if we draw a full circle all the way around the entire thing, the circle would go out 12 inches on each side.
Yes. No. Yes, I know. Yes, no. I don't know.
That's the only way I could see it making any sense. Because the radius is going to have to go out to the diagonal of all four corners and equal the same radius all the way around.
So what do we try to solve in the first place?
So I think we need to solve it for the radius. Because if we can find the radius, because this is going to look the same on all three sides.
I wonder. I have an idea, but I don't know how good it is. Say we could solve this triangle up here. Would that work to solve this triangle down here, or no?
No, because I'm pretty sure that the 12 inches, there's at least a foot. I don't know. I don't think it's only because I was asking to get us a foot high, but I'm sure the garage is probably at least 7 or 8 feet high.
If not, it was an idea. It was a hopeful thought.
If we can solve the inner triangle for anything, that'd probably be the best thing for us. Because we have this essentially. We have this circle here with a diagonal with a triangle in it.
Yeah, that's what it is.
Because this would be like the other 12 inches right here.
Mm-hmm.
And then that's the other part there. So this is kind of what we have. The origin of the center was the adjacent side. So there it is again. That doesn't help us. Let's get us pi. By the Pythagorean theorem, we know the following relationship among r. So it's x squared plus y squared equals r squared.
Which is what I put.
Is what you've got. If we normalize the hypotenuse to the length of 1, that is set r equal to 1, then we can call the resulting circle a unit circle. In this case, a circle intercepts the axis at positive 1, negative 1, and x equals negative 1, positive 1.
That might be an idea.
As you probably recognize, then 2 pi is also equivalent to 360 degrees. Segment of length r, the radius, and mold it into the circle. The angle formed by the radii connecting the center of the circle. 1 radian. Sure, that 1 radian is part of Oh, so if we convert 90 degrees to radians, would that help us?
I don't know.
So C is negative pi over 2 radians, but I don't know if the proof that does.
Say what?
So what's the hypotenuse? Is it adjacent? What is it? Is that tangent?
Opposite.
It's opposite over hypotenuse?
No, wait. The hypotenuse. Wait. Say that again. What were you trying to ask?
How do we find that r? Because we've got an angle. We have one side and an angle, so we can use one of the sine, cosine, and tangent things to solve for the other side. And then we can use the sides to figure out all the angles. So what are the... So I could use... Well, those are only for sides, huh? Where's the angle? I don't know.
This is so horrible.
So we have 1 foot in the arc. And then probably 2 feet down. So it's probably 3 feet. It's probably 9 feet tall. It's probably a 9-foot circle. I don't know. So we're just trying to solve a circle, right? Like, is it really that hard?
Shouldn't be. Oh, I just noticed if you found y, you could add 12 to it, and it would give you the same. It would give you the radius. Because they're the same length.
That's true.
So r also equals y plus 12. Hey, that might be a system of equations right there.
Now can we just solve for y or r or something?
Maybe. So then we have y plus 12 squared equals 9 squared. Yeah, we could. We only have one variable now.
Good. So if we get rid of what? The y squared somehow?
In the dark of the night, people will find her. Sorry, I was watching Anastasia recently. Excuse me.
I'm almost ready to just take a 0 on this quiz and call it good.
If we didn't get a 0, we'd at least get a 33.
That is, if we did the first part right.
True. I've gotten worse grades in this class. Well, no. A 0 would probably be like the worst quiz grade we've ever gotten in this class. Unless you've forgotten to do a quiz or something like that.
What the? That makes no sense. Come, my minions.
Oh, I love when my brain is fried already at 6 in the morning.
Not the best. I don't think this is going to work, guys, unfortunately.
That equation?
Yeah. Because it gets you y equals negative 21 over 8. There's no way you can have a negative distance. And either way, if it was positive, that's about 2.6 feet. Which, yeah, no. That's possible, but no. Good grief. How does that not work? Wait a minute. That should work in theory. Why does it not work? If you squared it, that might work. Because r squared. Yeah, that might be it. .89. Maybe. No, there's no way. There's no way, because it'd have to be longer than 9 feet, and that's not longer than 9 feet.
Okay, so our width of our arc is what? 18? It's that long, right?
Yes.
And then our height of our arc is only 1 foot.
Yes.
Because
Yes.
that's the height of the arc at all.
Mm-hmm.
How tall is the garage? Because if the arc's a foot tall, all right. So our circumference equals 2 pi times the radius. But we don't know the radius yet. So if we need to find the radius, we would divide it so it would be the circumference over 2 pi is the radius.
Mm-hmm.
But we don't know the circumference of the circle at all, do we?
Nope.
So that one probably won't work. We could find the area, which is pi r squared, but we don't know the radius. And we don't know the area. We have the diameter though, right? We have the diameter because it's 18.
Yes. Yeah.
So this says that you can use the radius equals the diameter divided by 2.
The
But that
radius.
just finds that's 9.
No, that's not gonna work.
Well, no, because that just come out to be 9.
So that'd be the diameter of the arc. Maybe not the circle. I have no idea.
It'd be the diameter of the arc, not the whole circle.
Yeah.
Because the circle would continue out another foot on all 4 sides.
Yep.
Oh my gosh. So arc length equals 2 pi r times the circumference divided by 360. But we already know the arc length. Well, it's weird because we already know the radius of the arc. We just don't know the radius of the circle.
Yes.
Freak, I have no idea.
I'm completely stuck on this problem and on the problem before this.
We all are, unfortunately.
Circle arc equation formulas.
For real, though.
Central angle, I don't freaking know.
What's the original? Can you scroll up a little bit?
So we need to find the central angle of the circle.
This one?
Yeah. So if we could figure that out, then life would be good. So if we cut it in half again, in the center of the circle with a line that cuts it in half, that would get us nowhere except for the fact that we knew that the line would equal 180 through the circle, but oh frick, I have no idea.
So the student brought this question to the Idaho mathematics faculty, and so they couldn't solve it. Therefore, they're passing it over to us and grading us on it.
Yeah, kind of shady, but
I just wonder if every other group struggles as much. I just feel like I have no idea what's going on sometimes.
And it's frustrating because like the purpose of these quizzes is to like, and the purpose of the individual quizzes on the weekends is to like prove what you need to study stuff for the exam and like what you've understood from the homework. But I have understood nothing from this, like, and I haven't seen anything on this in the homework. Like, this wasn't even in the preparation problems.
Nope.
So how are we supposed to know how to do this and get graded on it as a quiz if we've never seen this before? Like, I don't know. It's a pre-calculus class, not calculus analytics. But
Nobody knows.
it is what it is. Can't change it. All right.
Because I found everything. If we can find the central angle, there's a bunch of formulas on how to like find everything else. Just if you know the central angle.
You already tried the cosine thing? Sorry, when you guys were talking about that problem, I was like running tons of situations in my head about the problem before, trying to see if I could solve it before you guys got back.
For real. No, we could try that, I guess.
Well, I tried to use like the law of cosines or whatever, but it's you still need. I don't know. Because we have an angle and a side, but you can't solve for anything else with just those two, right? Don't you need three?
No, you can solve it because you could say so cosines. So it's opposite over
Hypotenuse, but that's saying for two sides. We don't have any. We have a side and an angle. Unless we solved for a triangle up in the top of the circle, like Chris was saying before, then we have 90 degrees, 9 feet, and 12 feet, or then a foot. And then we solved for that little triangle, but I don't know if that would do good for us.
Well, I don't think we have much of an option.
Well, can't we? Yeah, we can solve for the triangle above it, and then use the law of cosines to solve for the triangle below it, and that would give us the distance. That would give us y. I think. I don't know.
Would that though?
The problem is the above triangle is smaller than the below triangle, so that's. Oh, freaking heck. Oh, how I love this math class. All we need is the radius of the circle. That's all we need, right?
For real though.
So if we drag, well, actually, you know what we could do? Because the 9 feet will be all the way across. So if we drag the 9 feet down, That's 18 feet plus 1 foot on each side for the other circle. So wouldn't it just be 20 feet for the radius?
To what?
Well, so you see the dotted line at the top?
Uh-huh.
Just drag that dotted line down to the center of the circle. That's still 9 feet all the way across. And then we know that there's 12 inches on each side for the arc, because that's the arc one. And so you'd add 1 foot on each side. So you'd have 18 plus 1 would get you 20 feet all the way around. So that's the radius, wouldn't it be? Makes sense to me. Because if the garage is 18 feet and right there above you, you got another foot for the arc, it's going to be a foot on all 4 sides.
Sure. Yeah, that makes sense.
So wouldn't it just be 20 feet? And then the radius would be, well, no, because that makes the radius 10.
Ugh.
Well, yeah, that would work because there's 20 feet. I'd say it's 20 feet.
Honestly, let's go. Let's roll with that because I'm so dumb. But how do we use this solve before it?
Nobody knows.
I like how she put in the problem description. It's gonna be hard to think of it, especially if you've never seen it before. I didn't say the second part. I'm still bitter. I need to get
For
some.
real. Wait. Say what you're saying again. So you're saying that the radius is 20 feet?
Yeah.
I'm going to do that because... Wait, explain again how you knew it. Oh, right.
Because it's 18 feet across plus a foot on each side, and you just drag it down to the center. That gets you 20 feet on.
See, this thing is not drawn to scale. That's what's making it really frustrating. Which, I guess, how could you?
Draw a 20-foot building.
Plus 1 foot on each side for the arc. I don't know how we would apply the system of the equation to get there though.
Yeah, me either.
I mean, I had something going there for a while, but it just did not.
Freaking heck.
The radius is 20 feet. I don't know how we would solve that using system of equations.
I don't know how to solve it without using a system of equations.
See, I don't know why this doesn't work. It makes sense why it would work. Wait. R plus 12. Oh, that's not necessarily true. I just realized that's why it doesn't work.
Well, it's not necessarily true. My logic?
No, me. Y plus 12. This distance y plus 12 doesn't necessarily equal this length. How would we know what? Okay, so we know this equation is legitimate. That equation we know is legitimate.
Let's see. So the arc length is 18 feet, right?
Mm-hmm.
And then we have the radius. No, the radius is 1 foot.
Be right back.
I have no idea. I don't know. So if it's 90 degrees, then that's going to be pi over 2. Wait, that's a 90-degree angle, right? Oh, we're dumb. That means the other two angles are 45 degrees. Because in all right angle triangles, it's going to be 45. So we have 90, 45, 45, and that gives us enough to solve for the other three sides.
It doesn't have to be all 45-degree angles.
In a right triangle, I'm pretty sure it does.
No, because you can have a right triangle with one distance really short, and then even though it makes 90 degrees, the other angle or the other line could be super long, and that would make the angles not 45 and 45. Now, if the radius, I guess, if y were 9, then yeah, the angles would be 45, 45. But as soon as y is a different number than 9, they're not 45 and 45 anymore.
Oh, that's true. Oh, Bob Saget. I don't know how to solve any of these. I've just been like looking them up and everything that like for like distance and rate and time, it's like, oh, if one does it twice as fast, and then but it doesn't tell us that, so I freaking don't know.
Any luck? Any luck? Did we find any luck with solving this problem?
I mean, so you know how we were doing the other triangle to try to prove the first triangle?
Mm-hmm.
So the angle that connects with the 12 inches and the arc,
Uh-huh.
that one is 36.86 or 87, I guess. So I'm trying to figure out, remember weeks ago we did that thing where it was like the law of cosines or law of tangents or whatever, where you were able to say tangent of this angle divided by this is equal to tangent of this angle divided by that.
Yeah.
And I was trying to do that to get the angle that's opposite of that. Like the angle that's in between R and 9 feet.
Yeah, this
Furthest to the left angle, yeah, that one. But I couldn't remember that equation.
crying out loud. Yeah, I don't know what she's trying to pull here, but
I just don't know. I'm freaking confused.
there we go. What does y equal? Y equals r squared minus 9 squared. Yeah, that would work, maybe. Maybe. Try that.
Well, no, because that'd have to be y squared equals, yeah.
Yeah.
Yeah, sure.
Yeah, why not? Oh, gosh.
Well, because then you would end up with the equation r squared equals r squared.
I knew it was too good to be true.
Which, I mean, is technically correct. That's not wrong.
R does equal R.
What does y equal then? Y would equal the square root of r squared minus 9 squared? Try that. Does that work?
It's already 11. Holy cow.
I gotta get going soon. I gotta take a shower and get ready for work at 11:45.
Well, this is just. Would that work? Yeah, then after this, you'd get R equals. To that, you'd have.
You would just get R equals 9.
Oh, this is so frustrating. So quantity squared. You just get 9?
Yeah. Because if you take the square root of those, oh, you have it squared right there.
Yeah, because it's y squared. I'm doing a little substitution. Does this work or not? Be the someone tells me it's not so. Oh, gosh. Yeah, so tell me that y equals -9 again. R equals 9. That doesn't work. Try it a different way.
Oh, freaking heck.
Yeah, either way, it tells me it's 9. Which is not.
I have no idea. My head's starting to hurt thinking about this so much.
Well,
And I know we can't just like leave it blank because we don't know how to do it, but
that's the problem. What do we do?
Let's just put the answers for 2. Let's see, if they do it in 5 hours, that means that together they do it in 2.5 hours, assuming they do it the same rate. And so if one's at 2.5 hours, it takes an hour and a half longer than what's his bucket. That would mean that
the same rate.
you know, it's all good. And they just push the cart until they get to 3 miles, and it doesn't really matter how fast they do it. Oh, I don't know. Just frustrating.
Like the way every single time that I do it, I trip myself up thinking because if you were to try to do the substitution method and substitute in an equation for the first equation, or for one of the variables in the first equation, you would have it being equal to their original rate, and you can't have them equal to their original rate.
Yeah, I have no idea.
They're at different rates.
It has to be longer than 5 hours. Really, this is so frustrating.
So, do you guys remember last week how I told you that I accidentally did the wrong quiz?
Uh-huh.
Yeah.
So it was this quiz.
For real?
Yeah, this week's quiz that I was trying to do last week.
No wonder you're so lost.
And if I'm being completely honest with you, the quiz didn't look at all like this. Oh, you're not here still. I mean, I can't obviously tell you what was on the quiz. Or do you guys want me to tell you what's on the quiz?
I have no idea. Probably wouldn't help anyway.
Obviously, I mean, there's one with systems of equations, and we already know that.
Oh. Oh, man. For hours working by himself and just has a 3 hours. Makes no sense. Not even Google search. A Google search even is coming up dry.
I've searched everything that I could possibly think to like help. I can't find anything.
I mean, I got an answer earlier that I have no idea how it makes sense, and it probably doesn't, of 6 2/3 hour.
How long does it take them to decorate things individually? Oh. This is just an additional exercise for them. I don't want to do additional work. Honestly, if we can at least get this, maybe, then but so here's one, and it says everything that I can see, it says alone it takes him this long to do it.
Yeah.
Or this is how long it takes him to do it, not this is how much longer it might possibly take her to do it. Well, here's this. So let F equals the number of the hours it takes for Mary working alone, and 2.5F equals the number of hours it takes Peter working alone. So 1 job over F plus 1 job over 2.5F equals 1 job over 12.5 hours. Solve for F to get F equals 17. Working alone, Mary takes F, 15. So here's this. It's literally the only thing, but it actually doesn't really tell us how to do much. But this is the only thing that I can see where it is somewhat the same. So they do a job in 5 hours, right? Or was it 3 hours? 3 miles in 5 hours.
Mm-hmm.
How long does it take Mary alone to do the same job? So they put 12 point, no, they put, the heck did they do? And solve for F.
So
Don't worry, guys. This is only a complexity of 1.
together they do a job in 12.5 hours. So together they did a job in
5 hours.
in the 5 hours. Should equal 1 over John plus 1 over oh, this is freaking frustrating.
Freaking ridiculous is what it is.
It takes Sarah 1.5 hours longer to move the handcart the same distance when she's working alone.
So her would be 1 job over something else.
1J minus 1.5.
So J minus 1.5?
Yeah, equals Sarah. Because Sarah has to do an extra. It could be S plus 1.5 equals J or S equals J minus 1.5. Both of those are the same thing.
So it would be S plus J equals 5 hours and 1. What did you just say? You just said something.
I just said S plus 1.5 equals J or or S equals J minus 1.5.
Would that work? Yeah, that might work.
If you do the substitution method.
Mm-hmm. Let's try that.
So you get S plus 1.5 equals 5.
Well, you don't have much of a choice, I guess. We could.
Subtract 1.5 from each side, so you have 2S equals 3.5.
2S equals 3.5.
And then S equals 1.75.
S equals 1.75. That gave it. That told us absolutely nothing.
What is it good for? Absolutely nothing.
Well, I mean, that's why it would be smart to do. I feel like it'd be smart to do the rate first, because then you could multiply it Well, what's... Hold on.
She's working alone. Equals the trip. Equals R, the rate.
Our rate is 0.6.
Check that. Yes. And then 1.5.
So here they did 1 over T1 is the time taken by the first person plus 1 over time 2 taken by the second person equals 1 over the time together. But we still need to figure out how it takes to do one person.
Well, it takes Sarah 0.46 miles per hour to do her job.
So if she goes 4.6 miles per hour, you'd multiply that by how many hours?
Well, it's 3 hours.
I'm still listening, guys. I just have to start getting my clothes ready so that when I have to peace out, it's not... I don't have to rush to get everything to work.
Oh my freaking goodness.
Wait, so can you just plug S in there since it's S plus J equals 0.6? Just put the 0.46 in, subtract it, and that equals J?
Supposedly. Well, we could try it.
But that's how many miles he worked per hour, right? Which would actually make him
Yeah.
slower than Sarah. So
He could be slower than Sarah. We don't know.
It says that she's slower than him.
she takes longer.
It says in the hint. It says it will take him longer.
No, it says it will take him longer than when he works with Sarah. So he takes longer alone than to do it together, but she takes longer to do it alone than he takes to do it alone. So in order of speed, it would be them together, then John, then Sarah.
What is it good for?
Does it say
Absolutely
that?
nothing.
That makes sense, Chris?
I'm trying to see where it says that. She takes
Well,
1.5.
it says in the second line that Sarah takes 1.5 hours longer to move the handcart the same distance when she's working alone than it takes with John.
Oh, then it takes John. Okay.
Yeah, so it takes her longer to do it alone than it takes John to do it alone.
Oh, so it takes her 1.5 hours longer to move the handcart than John does.
Yeah.
Ew, gotcha. Don't. Sarah equals J plus 1.5.
Yes. Except we can't put those together because that's a rate. The 6.5 is a rate. So we're sticking with hours.
Yeah, sticking with hours.
It's 5 hours. So what was the answer that we got?
That work?
No. Well, what was the answer that we originally got?
I don't know. I don't remember.
It was like 1.75, I think.
But that doesn't work because that's slower than Sarah.
Yeah.
Gosh, dang it.
My brain is seriously just fried right now.
I don't know
But I
what.
still have all the math homework to do too.
Thank goodness I have it all done. That would have been
Well, I
yeah.
finished the first one, but I still got the other 3.
This week was the first week in like 2 weeks that I had even attempted to do the my math lab. Like I looked back at my like past due, and it's like 6 of them in a row. I'm like crap. But they don't even affect your grade that bad, anyways. Like I mean, they do a little bit, but it's.
Well, that's what I don't understand is like I've done so many assignments, but still everything's still only worth 110 points, So did they put like everything in all at once and then you're just like slowly clawing your way up?
Sucks, man. This sucks. So would this work? J plus 1.5 plus J equals to 5. Sure if that works.
Then you have 3.5 is equal to 2J, and so J would equal 0.75 or 1.75.
Oh yeah, that's what you had before. I think. Well, okay, we have J equals to what? 2J equals to what?
1.75 or 2J equals 3.5. But the issue is that when you divide that number, so the rate was 3 divided by 5, but when you divide,
well, times it then. Do 2 over J because that's the time of job, and then it'd be 1 over 2J, and then once you'd multiply it over, then you would get to 7. So it'd probably take him 7 hours, and then we can plug it back in for John to find Sarah.
we don't need to find Sarah. I think
Sarah.
we need to find John.
Well, I know, but we've already found John, so might as well find Sarah too. I'd say 7 hours. That sounds pretty reasonable to me.
Yeah, we accomplished one thing. Sarah. Well, Sarah. Simple. Yes.
And then Sarah equals 7 plus 1.5, which is 8.5 hours.
Yeah. Screw you guys. Work together like a good happy couple. Okay, we got that done. Now let's try to tackle this garage nonsense. Hey. We got it after some time. Okay. Okay. We got one, we can do this. Right, gang? Okay, so we know this equation is true, right?
I have no idea.
Well, this is just the
All right, guys. I'm sorry that I have to do this to you, but I have to go. I have to get ready for work.
It's all good. It's all good. So we know that.
I'll see you guys on next Tuesday, hopefully.
Hopefully.
All right. See you guys later.
Peace. So we know that r squared equals 9 squared plus y squared because that's the Pythagorean theorem, correct?
Yeah.
So what other equations could we put? What is y? See, that's what I was trying to say. What does y equal?
I really have no idea is my problem. I don't know. I say we just call it good because we're not going to figure this out, and I got to get going for the day.
I can try to figure it out. Well, shouldn't y equal r minus 12?
Yeah, that makes sense. R equals y minus 12.
So we'd
Or no,
have
it'd be r plus 12.
r plus 12, right?
Well, no. You're right. Sorry, no, you're right. You're right.
So we'd have r squared equals 9 squared plus the quantity r minus 12 squared. Try that out. See how that works. And then, yes, after this, if this doesn't work, I'm just going to have to say we'll call it good. This is taking way too long for any of for our sanity. R squared equals 9 squared plus...
We need to get rid of the y, right?
Yeah, so we just did that. I plugged in... Oh, yeah. So I took what y equals r minus 12 and put it back in for y. So r minus 12 is squared.
Because if we times... So we got to find y.
It says
So we got to
that
get rid
r...
of r. So if we subtract the r over, r equals y minus r minus y. And then we could add the 12 over. Or I guess we could just subtract the y over and equal it to 0. I don't know what I'm doing. I have no idea.
I'm getting 9.7, 9.3. That makes sense.
No, that works for me.
I'm saying I'm just gonna say that works because, so that'd be, what's 9 feet and 0.375 of a foot. It'd be 4 inches, right? Because 12 divided by 3 is 4. And 9 feet and 4 inches, does that make sense? Does that even work? Does that work?
Yeah. Makes sense.
Okay, we're just gonna call it. We're gonna call it.
Let's do it.
That was way too long. Well, have a nice day, everybody. Hopefully that next time it does not go on for way too long. I'll see you all in another life.
The other one. What other life? This is life. All righty. See ya.
See ya.